Space Division Multiplexing (SDM) based NCEDFA. Dr. Arya completed one DST Cert Fund project as a principal investigator on silicon-based optical modulators for high-speed optical communication systems under the Young Scientist Scheme of Government of India. He is the nodal officer in Nehru Shillong for the Viswesvar PhD scheme phase 2 of the Ministry of Electronics and Information Technology MEITY, Government of India. Dr. Arya developed two postgraduate courses, Silicon Photonics and Photonic Integrated Circuit for MTech ECE students in the Department of ECE, Nehru Shillong, in light of the new education policy NEP 2020 of Government of India. He developed a lightwave communication system LWCS research laboratory in the ECE department Nehru Shillong. He was a recipient of ISM JRF Research Fellowship while pursuing PhD in RBM doped fiber amplifier at IIT ISM Dhanbad, erstwhile ISM India during 2004-2007. Before joining Nehru Shillong as associate professor in 2010, Dr. Arya acquired 3 years of full-time teaching experience at ISM Dhanbad. His research interests include silicon photonics, EDFA, advanced modulation formats and multiplexing techniques, and optical fiber communication, modeling, designing, and fabrication and data analysis of photonics devices and circuits on SOI for PICs. He has over 90 research publications, mostly in journals and reputed conferences. He is a fellow life member of Optical Society of India. May I would request Professor Arya to start his presentation. Sir.
Sorry, just 1 minute, sir. One announcement is there.
One more announcement. All the oral presenters, you are requested to load your pen drive on our PC. Okay. So let me just tell the names of the participants who have already reported to us. Dr. Medelson Ranghang, Vikas Chandra Busahari, Beatrice Bosumatari, Dr. Pranjal Hazarika, Vikas De, Dr. Ranjit Datta, Dr. Femina Brahma, Dr. Suresh Kumar Dan, and Medhika Bosumatari. And Professor Dr. Joginder Singh. If he is there, I think he has not turned up yet. Sir, you can start.
Good afternoon to one and all here present. Respected Professor Pawan Kumar Sharma sir, Dr. Chinmay, Dr. Prince, faculty members, students, ladies and gentlemen. I think now to draw attention for this session is really a challenge for me, but my talk I think shall able to connect you. Just say hi, Puni, Gozen. I think everyone should wake up. Puni, Gozanye. So, topic which I am going to deliver is like this: science and technology, a pivot of human civilization and existence. When this invitation came, it was very difficult for me what kind of content I should incorporate in this presentation, because I was apprised that in the audiences there is a large spectrum of students from undergraduate, postgraduate, faculty member, researchers, and so on. So I try to frame. Hopefully, I shall able to fulfill your aspiration. So before coming on that, first accept my greetings from Northeastern Hill University, Shillong. On this auspicious day of National Science Day, I congratulate you. This National Science Day is celebrated in the name of C.V. Raman's invention on Raman effects. Then I shall express my deepest gratitude to the registrar, Professor Shubham Bashmatri, who has invited me to deliver a talk. I am thankful to Dr. Prince. Because of him, I am here, and I am thankful to Ms. Bandi Lankarsati, who has connected me from Northeastern Hill University to this Gala Festival of Bodoland International Knowledge Festival. So thank you to all from my bottom of heart. So the aim of my talk under this bigger heading that science and technology, a pivot for human civilizations, are like that. This is the outline. Basically, this is the outline under which I plan to deliver a lecture. Here, first I will take up the aim, followed by objective, then the dynamic meaning of science and technology. How, due to the passage of time, the meaning of science and technology itself has changes. So whatever meaning was in ancient time, now it is no more as such relevant. But let us have a recap. Then brief history of science and technology in abroad and India, just a bird's eye view. Then the race between science and technology and education, how it is going to impact on society, that I will explain. And then fundamental duty in context of science and technology. You know, this festival is being organized to develop a knowledge-based society and economy. So to develop such kind of knowledge-based society and economy, one has to develop, or citizen has to develop scientific temperament. In that line, I shall recall this Article 51AH of Indian Constitution. Then opportunities available to young researchers, particularly in the field of IC designing, more specifically silicon photonics, and followed by the conclusion. So when I saw this process in the flyer, I have been given that this entire session or the knowledge festival will take care of the episteme, the intents and perspective, praxis and solution. So in that line only I try to meet these things. So to develop knowledge-based society and economy, this may be looking a newer term, but that is what is the main purpose of this knowledge festival. So I try to connect with this theme. In order to achieve this aim, I shall try to explain the meaning of science and technology as already told, then historical development, assessing the impact of science and technology development and education. There are two things, science and technology development and educational level development. So these two things I shall try to take up, then recalling fundamental duty and available opportunities. So we are very familiar so far as economies, different sectors of economy is concerned. So we know this primary sector, which is basically agriculture based, mining based on natural resources. Secondary sector based on the industrial product, which is taking the raw material from the primary. And then tertiary sectors, which comes basically service sectors, banking, marketing. But in a recent past, two more sectors have emerged, that is quaternary and quaternary. In quaternary sectors, basically this influence the economy in terms of knowledge production, knowledge development, creation, research and development, business consultancy, financial, educational institution, public administration. And now this fifth one, that is called culinary. So government of India is also emphasizing the leadership development. If our leader are enough foresighted, so they shall able to take a decision which is going to influence millions of people. So this is where a new sector has emerged so far as different sectors of economy is concerned. So, what is this knowledge society? In a knowledge society, people are not only able to acquire the information from different sources. We are getting the information from your electronic print media and a newspaper, journals, articles. There are so ample of information are bombarded over on us. But how to understand, or in what way we can understand in a better way? Are we able to demonstrate? Are we able to comprehend? Are we able to uh, explain in our own language, say oral language? So that is called comprehension. So in a knowledge-based society, people are enough able to explain those things, apply in their own circumstances, can improve their livelihood. That is the essential ingredient in a knowledge-based society. So the overall purpose of this knowledge-based society is, after acquiring, applying, then we should able to analyze those information, synthesize, assess or evaluate, and then create new information. So that is the essential features of a knowledge-based society. And in this, every citizen has to play a role for the nation building. This is where I try to draw attention to this term. Now, knowledge-based society, we can see it is present situation emerges after 1915 due to digital revolution. Before that, we have seen this industrial revolution, and in ancient time, agrarian society where food, shelter, etc. were the main features or main issues. So this is a radar graph which compares the two giants country, India and China, on different parameters of knowledge society. So you see, except rule of law, we are lagging behind. Although this data is older, but more or less trend is same. So this data has taken from the World Bank. So, so this knowledge-based society can contribute a lot to fulfill this gap and to move our nation ahead. Now coming on this dynamic meaning, so you see about 7 million before, when human civilization started, there was a revolution which is called cognitive revolution. That cognitive revolution makes us or a human brain enough to speculate, enough to dream, enough to write stories, enough to write mythologies. So to explain our phenomena, it was one of the biggest revolution which makes us human being. Otherwise, uh, we and chimpanzee, which is the nearest ancestor, we were the same. But this cognitive revolution has made some different. Then followed by agricultural revolution. So in during this cognition revolution, what were the issues so far as science and technologies are concerned? Issues were, we created mythologies, stories in order to explain the natural phenomena, how rains is occurring, how how days coming. So this was this was the important feature of a human being. Animal cannot dream, they cannot speculate, they cannot create a stories, which is very essential component. Now, in agriculture revolution, food, shelter, defense were the component of science and technology. This was that period. What is the science and technology, if you ask? Now, in third one, during industrial revolution, astronomy, physics, medicine, machine, in the industrial revolution occurs in 17th, 18th century in Europe. that is also called Renaissance period, of course. But you see that revolution, industrial revolution, were able to develop new machines, electricity. It was able to solve the manual problem. But on the other hand, there was another issue which I will just come in. Next is the digital revolution. In the digital revolution, we can see the computer technology, development in the computer field, biotechnology, communication, defense, space, and so many other fields. These are the issues, these are the topics when we talk about science and technology. So you see, throughout the ages, the meaning of science and technology, uh, that is the systematic study based on the observation, experimentation, and application. And later on, technology which uses science to solve our day-to-day life, to apply those scientific knowledge in order to solve human problems. So that is the technology or application aspect. So in all duration, the meaning or overall meaning changes. Now, this image, left-hand image, we have seen many times, and it is prevailing understanding that we have evolved from the great ape, which is not a this is the unscientific description. Basically, 7 to 6 million before, we Homo sapiens or say human being and chimpanzees having the same ancestor. We were having the common ancestor. And after this mutation, selection, and genetics, we digress. We digress and we evolve as a human being. That is what is called cognitive revolution takes place. So, right hand side image shows the correct explanation of our human evolution. Now, next one is so far as human beings are concerned on entire Earth, whether it is black Negroes, white Europeans, Asian, Mongolian, or any part of the world. In terms of DNA, we are all same. 99.9% we are all same. So there is a philosophical meaning. Although differences are there, uh, but uh, in order to predict susceptibility of diseases or reaction and adaptation with the environment, that they appreciating those differences, but you see similarities are high, and this 0.1% difference in the DNA covers entire things like eyes of color, hair, height, our behavior, etc. So here I want to tell that whatever conflict we are facing in this world, we have to understand that biological DNA in terms we are all same. So after that, one more important image I would like to show here, that is popularly known as pale blue dot. This image was taken by one spaceship called Voyager, NASA's Voyager. It captured the image on the request of Carl Sagan, an astronomer, to see the image of Earth. Earth, you see a very tiny particle, a dot. You know, from that he tried to give a message that entire Earth is looks like a dot. In the universe, we are traveler, a lone traveler. Till now, we are not able to identify there is another space, another planet is there where human exists. So how negligible we are. So if we see from bigger perspective, all these everyday fights, that doesn't matter. So this image has motivated Carl Sagan to write a book on this very topic that is called Pale Blue Dot. So now this historical development of science and technology all are familiar. Prehistorical time like farming, housing, food, fire, wheels, they were the milestone, followed by in 15th, 17th century, we discovered new world called now America, South America and North America. Then dark continent, we explored dark continent that is Africa. And we explored new sea path through which we can connect entire world. So world becomes a family, global family. And the topic of National Science Day is also a global science for global well-being. So now, this 18th to 19th century industrial revolution steam engine was invented by James Watt, then electric bulb, Thomas Alva Edison, and motor car, the electric motors, etc., which have contributed a lot. Michael Faraday has invented this one. Now in 20 and 21st century, electronics and communication has revolutionized. You have seen the contribution of say electrical, computer, etc. I need not to explain all are familiar. The medical field, etc. So far as India's contribution in science and technology, particularly in pre-India, you can see we have C.V. Raman, a Nobel laureates. Then Meghnad Shah, who invented ionization equations. Then Jagdish Chandra Bose, he was physicist and botanist. He invented Kescograph and wireless communication also. He has contributed a lot. Then mathematician Ramanujan Srinivas, and in the nuclear field, Homi Jahangir Bhabha has contributed a lot, which makes India nuclear power. So after independence, with different revolution, government of India has taken this as a moment, and uh, Swaminathan has brought this green revolution through which lot of crop production, grains production, we were self-sufficient, and we were not only able to self-sufficient in the grain or food production, but also able to export. Then a white revolution through which we have produced enough milk to feed population. Here, this has contributed a lot. The blue revolution through which we see seafoods and fishing etc. Could contribute in India as so far as science and technology, then medical field and ISRO. Who doesn't know about ISRO? Now, I like this right-hand side curve very fondly. You see, on x-axis we have time, and y-axis this curve shows the race between science and technology, or say technology and education. So two components which I was trying to tell that initially in the time of agriculture revolution, the level of technology and education among the population both were same side by side. But due to industrial revolution, there was a steep rise in the technology development. However, lot of masses were not literate. They were illiterate. Education was not so much accessible. So what was the outcome? You have seen that during industrial revolution, lot of countries in the world colonized, including India. People were exploited in the industries. So the gap between education level and technology was huge, which results social pain. And this social pain also was the outcome of First World War, Second World War. These were occurred during this industrial revolution. Although there was a tremendous development in the technology, but people were not so educated. So that is why when people realized that this social pain, they started giving proper attention towards the education. Educational opening the educational institutions right from this school education, secondary education, then higher education, giving proper attention in the R&D, reaching to the common people in terms of the education. And now we see After that, when digital revolution takes place, communication devices were affordable. People started using, level of education increases. We know at the time of independence, we were only hardly 70% literacy rate was there. But now we have about more than 74, 75% literacy rate is there. So that shows what? That shows the education level is now ahead to technology development. That if this gap is there, means education level is higher than the technology development, then in society prosperity occurs. So that's it. That is where knowledge-based society has to think. Our decision makers have to think about this aspect that each level of education should always be ahead. Now, in after the we are still in this digital revolution time. After that, because of this artificial intelligence, virtual reality, and then augmented reality, mixed reality, metaphors. Now the technology is now booming. So now this government of India has given a right call through new education policy that education level of masses should increase enough so that the level of education should be ahead always than the technological development. So both cases are shown at topmost this right side. If the level of technology is ahead to education, then social pain. If education level is more than technology, then social prosperity. So it depends on now our decision makers, policy makers, and this is a very good occasion also to draw all of your attention in this knowledge festival that we have to decide where what we want, social prosperity or social pain. Although technology will develop, but now we have to give proper attention on the people's education. Next, I want to just recall, as already hinted, that Article 51AH tells that it shall be the duty of every citizen of India to develop the scientific temper, humanism, and the spirit of inquiry and reform. You see, in our, in our traditions also, in our philosophy also, 2005 years back, Lord Buddha told what should be the criteria of acceptance or belief. It is not necessary and sufficient condition that you should believe because I am telling by sitting here. This is not a necessary and sufficient condition. It is also not a necessary and sufficient condition that something is written in my holy book, that is why I am bound to follow. This is also not a necessary and sufficient condition. Now, third one, something is coming in a tradition. Why I am following? Because my forefathers, my ancestors were following. That is why I am following without giving my own mind or logical mind to understand. That is not a necessary and sufficient conditions to be followed. But there should be, you should apply your own mind. You should see whether by taking this step, it is going to give, it is going to harm negatively to other people or not. It is for well-being or not. This should be a criteria of to follow or to reject. So these things, you see, these things require a scientific temperament, which is already enshrined in our constitution under Article 51, heading fundamental duty. So now coming on this opportunity, because this is science and technology, and young generation must be expecting something from there. What I can suggest here to you people. So, India happened to be relatively poor in terms of IC production, integrated IC. Still, Taiwan, Singapore, and Belgium, and other countries, small countries are able to not only manufacture the ICs, integrated circuit IC from their own fulfillment, but they are able to export. But although few efforts were put from India side, but we are not. Present government has also given proper attention and given a call that is called billion meets million. Means billions population needs million transistor. With this call, electronics and Minister of Information and Electronics has given a call under that. And in I came to know in Gujarat, a foundry is going to establish Vedanta and Foxconn will develop that foundry to fabricate the integrated ICs. Now, so yeah, this slide shows that what are the opportunities. Presently, I can tell you may be also aware that through eFab platform, Google is sponsoring. Google is sponsoring the chip fabrication cost free of cost to the designer. Means you can design your IC. All fabrication cost will be bear by Google, and they are providing Sky 130 PDK process design kit, so that these happen to be industrial IP, means it is not freely accessible in the market, but this Sky 130 PDK is available to use by the designer. Now, this INUP, Indian National User Program, where electronics nanotechnology people can fabricate their IC, of course not for commercial but for R&D purposes. In first phase, INEP were established at IC Bangalore and IIT Bombay. Later on, in the third phase, IIT Guwahati, IIT Kharagpur, IIT Delhi, these were also included to be a part of INUP third phase. So there are a lot of investment have been done in order to develop fabrication facility in the integrated circuits. And there is one more platform that is called iSTEM. iSTEM integrates the resources available in entire India. These resources, these equipments or laboratory items are very, very expensive to develop integrated circuit or whatever to carry forward the R&D. And these happen to be taxpayers' money. But in order to reduce this duplicacy through iSTEM, young researchers can access those things and utilize those opportunities to fulfill their research and development. So here in right hand side, I just shown the image in which myself, I'm one of them in one shoot to when I visited IC Bangalore under INEP program to learn this how to fabricate integrated circuits. So now this is the silicon photonics where we manipulate the light generation, manipulation and detection of light on silicon platform. You know, silicon happen to be very poor photosensitive material. I say for photonics it is very, very poor because it is a indirect band gap material. But through plasma dispersion effect, now plasma word is very familiar to all of you. So through plasma dispersion effect, we are changing the refractive index of silicon material so that when light travels, we can develop constructive interference and destructive interference. So this slide shows the market forecast, particularly in the area of transceivers for data centers and communication purposes. So here this left-hand side image is a magenta interferometer. It can be used to design a sensor. For example, here coronavirus sensor we can develop, and principle of constructive and destructive interference can be used to detect that particular sensing item or material. So this is the slide which shows what we are doing so far as our research is concerned. So basically 4 areas in which in first area we work design and modeling of advanced modulation formats and multiplexing technique to increase the data rate in optical domain. Once we work in the optical domain, at least 1,000 times more bandwidth and then speed and the heat dissipation problem in the electronic domain is solved at once. So these 3 important things: bandwidth saturation, then computation speed and heat dissipation. That is why we are we are working towards photonic domain. That too using the existing and very much matured CMOS fabrication technology. So in order to design photonic integrated circuit, we use the same fabrication, same CMOS technology, so that we are not going to invest a separate foundry. Another area is this modeling and design of plasmonic material-based optical modulator. So which further increase the package density as well as speed, so that we can match with the electronics. Earlier photonics happened to be little bit uh, taking more space compared to electronics. That is called package density. So if we use plasmonic material, then this problem will be solved. Now, third one is this RPM dot fiber amplifier based uh, amplifier, of course, EDFA. And here I want to draw your attention on that. Raman has also given this effect. Raman, through Raman effect, also we can design a Raman amplifier which amplifies the light in optical domain, so that no need of 3R repeater for optical communication or optical networking purposes. So this is just a glimpse of how can we design an IC which is industry compatible on JDS layout. You can use K layout, but that is the open source software which I also use in order to design a silicon based optical devices and circuits. So these are the silicon wafer process which very compatible with CMOS fabrication. Mostly who are working in this area are familiar. And these are the application just below one, and above one is the simulation result. Here the opportunity which I utilizes through multi-project wafer is through edX course. Professor Lucas from University of British Columbia is conducting an online course that is called Silicon Photonics, in which I am also associated now as a teaching assistant, where students from throughout the world are enrolled. So in that course, they are giving the software sufficient study material in order to design. Then they take your design, circuit design, and fabricate in nano tool. And after the characterization, they share the results. So now the huge investment is not required so far as your research and development is concerned. So, so even sitting in your Pokhara's hall, this area also, you shall able to fulfill your dream of IC designing. That too particularly in the photonics domain. Here, if somebody is coming forward, I shall really be happy to help them. Of course, through this online course, I'm already happy. And in a year, 3 times we used to run this program. So these are the key publications. And now coming on this conclusion for which everyone is waiting. So based on the need, outcomes, trends, perspective, the meaning of science and technology is being changed. So now you have to define science and technology in present scenario, contemporary world like metaverse, robotics, artificial intelligence. That is your science and technology. Next, so major invention discoveries in science and technology from past to present can be classified into these three revolutions, that is agriculture, industry, and digital revolution. And now we are moving ahead also. Here we have to look whether technology should go ahead, or we should meet, education level should meet with the technology development. Now, further that, this the race between this technology and education will lead or will decide social pain or social prosperity. Then Article 51A H, we have to remember that one, so that a knowledge-based society can be flourished. Now, so far as opportunities are concerned, under INUP, then STEM, EFAB lab, where Google is supporting free of cost. That is wonderful opportunity to the young researcher. and through multi-project refer call, we shall able to design our own integrated circuits. So with this, thank you so much for giving me opportunity to be here, sir. And thank you so much for patience. Thank you, sir.
Thank you, Professor Arya sir, for your very nice presentation, which is relevant to the society and you are running one course, so our students will also be benefited from that, I think, because designing and electronics nowadays it is a part of undergraduate as well as the postgraduate syllabus and curriculum, and under NEP it will be more because practical based projects are there, so they can do those type of theoretical works here and then they can, I mean, get the results. Okay, once check that is checking their, I mean, the data also we done.
Yeah, we are also thinking that this chip designing or tape out of chip designing should be integral part of the graduate program.
Yes.
One, before getting a degree, one should be able to fabricate one IC.
One IC.
Yeah.
Okay. Thank you, sir, for your nice presentation. Now, is there any question? Because there is a paucity of time, since it's a very interesting topic. So, if one question at least from the audience side, we are expecting it. If there is no question, is there any question? Anybody asking? No, I think so. Thank you, sir, for once again. And I would now request our Professor Bailum, sir, to hand over the certificate of appreciation to Professor Arya, sir. Okay.
Thank you so much.
Thank you. Now, I would request our one more guest, invited guest, that is Professor Pawan Kumar Sharma, sir. He will chair the next session. I mean, in this the second session itself, the oral presentations are there, and we have as many as 10 participants. 9 have reported so far. So I am just now handing over the microphone to Professor Pawan Kumar Sharma. And we have another co-chairperson from our very own, Bailum sir is also there. So sir, I mean, you can assist also, sir, as a co-chairperson to Pawan Kumar Sharma, sir. Thank you.
Thank you very much. I have been told by the organizers that at 2 o'clock there is another program in this very hall. So I would just request that each one of you, the presenters, if we can stick to 5 to 6 minutes. Although you may think that you prepared so much, but you're getting a little less time. But let me tell you, my younger friends, that is also an art that even if you have a 1 hour presentation, if you're asked to present it in say 10 minutes, that doesn't mean that you use your first 3 pages. So use it as an opportunity, because at 2 o'clock I have been told by the organizers that there is another program in this very hall with a different theme. So I'll request my younger friends to stick to 5 to 6 minutes. So the first presenter here is Professor Joginder Singh. Is Dr. Joginder Singh there from NPU? I believe he's not. So the next one is Dr. Middleton Rongai from Department of Civil Engineering, Bineshwar, Brahma Engineering College, Kokrajhar. Dr. Middleton is there? Yes, sir. Yeah, so would you please come and present? And I would suggest that if you come to your work in the beginning, that will be fine. And all other presenters, you come prepared with your, you see the USB sticks to the desk on my right, so that they can load your presentations in the very beginning. So Dr. Middleton, talking about self-disinfecting system for rural groundwater supply scheme under the influence of surface water. All other presenters in the sequence, the next one is Dr. Bikash, and then Beatrice Pasumatari, Dr. Pankaj Hazarika, dAY. Everybody, please hand over your USB sticks to the desk on my right, so that they can load it beforehand, so that we can save time. Yeah, Dr. Middleton, please.
Yes, sir. Thank you so much for the opportunity. So I'm Madison Longham and I represent Minister for Engineering College.
Can you use the mic, please? We have a mic over there. Thank you.
So let's say I have this water. So ready. So this water, how safe it is. So today I'll be talking about how safe it is. So here is basically the challenges. I don't talk about much challenges. You can see 1.5 million are dying every day and 73 million of working hour are lost because of one which we don't know. And that's what I'm going to tackle it. What is so we're not talking about in detail how much expenses we are doing every day, which was not supposed to do it. Moving to the next, this is the story of Assam. Not only Assam, entire India, you can say this kind of story where our women has to fetch water, which that 73 million is counted here, the losses of working hour. Now moving to the next, this is the, of course, the beautiful of Assam, but the red dot signifies something very much not wanted. Moving to the next, that's a picture of where you can see that our wastewater or whatever we have been not wanted are disposed and we are drinking this water. Technically, we are drinking this water. So I have a solution. The solution we call it a natural bank filtration system. A bank filtration system basically what it is that if you have a source, maybe a lake, maybe a river, anything you say. So I request to have a bore somewhere very close to the river pump because of the hydraulic connectivity between the source and the well. You are going to take and filtered water, that means pre-treated water in one term. It could be sometimes directly consumed also. So basically, what is this? More important is that the mixture between the groundwater and the surface water. And what important is the distance, how far it is been drilled. So if you adopt this technology, you don't have to do calculation and any big infrastructure which is around 50 to 60 crore for an MLD of 10. So I don't need that 60 and 50 crore, only a few thousand rupees suffice my requirement. Moving to the next, I will not talk about it in detail. So some example why this bank filtration has been a topic of discussion today. A country like Germany, they have been adopting this technology more than 200 years. So you assume that if they have the purchasing power of more than 100 times than us, still they have been adopting this technology. Now this is one of the example where I did my PhD. So there is the people from there, the monitoring system are observed. But now moving on to the next, I'm not going to detail. There are some examples. You can only see that small well is there. Other no structure. But that is providing the population of more than 1.5 million of a country. Just think about it. We, Assam, I think only 3 million. So I think we can do it. Moving to the next, this is one of the water treatment plant. Of course, very beautiful from outside, you cannot see anything, but this is there. It's inside, it's a natural system. One more example, I'll not move in, go, let's go, let's go, let's go, let's go. This is the example of one of the walk where the water, because of brine water, they require a pre-treater so that the life of a membrane could be extended. So basically, what the pre-treatment, the seawater is being included to the bank filtration concept, you get a little bit lesser concentration or concentrated brine water. Then the cost of our treatment would be lesser. Some of the examples, so I'll not move. Since 10 minutes is coming to 5 minutes, let's move to here. Some of the example in India. So here is my extensive work I have done in Haridwar. A big casing well is that we call it IW18. 18 is the number, IW means infiltration well. So there, the water has been given to the Haridwar city. This is the Pori Ghat, some bathing snan place is there. So from there, we are filling the water. And here the last one, the Pathargarh in Kokrajhar, which I started with the support from DSC State Model. And it was a small project, but you can see that a gentleman from Germany has been working to validate whether in Assam, especially in Kokrajhar, is possible or not. And we found, I'm very happy to inform you that that is possible. You don't have to go for 60, 100 crore of investment to give out safe water to a public. Moving to the next, here is what I'm going to talk about. Now our disinfectant system basically what happened. Now when we want to disinfect water, what we do? We ask somebody, go and put bleaching powder, go and put something that kill the bacteria. How do we do it? We ask somebody or we train somebody and that trainer, maybe he is sick on that day. What will he do? वो तो कुछ भी डाल देगा. अगर कुछ भी डाल देगा तो क्या होगा? अगर क्लोरीन आपका पास ऑर्गेनिक है तो मिलकर क्या बन जाएगा? कैंसर कॉजिंग कंपाउंड. So PAC is a very dangerous compound. Now, if we see Assam, we need 12 still in Assam, there will something is wrong. Assam is a hotspot for cancer. Now, one of the reasons is this precursor cancer causing compound, which has been coming out during the process of water treatment. Moving to the next. So, this is my, there are so many projects which I am doing with my colleague from Germany, so I will not talk. This is water treatment which we are drinking the water. One of us are in Guwahati. Now, would you drink this? But we are drinking it. That's why we wanted to say that, okay, our project area, that's what we wanted to tell them, okay, starting of the story, how we start the project. Moving on next. That's the setup. Entire setup is fully automated. Industry 4.4. What is 4.0? There is about no human intervention because the electron from the chloride will generate the chlorine itself in the system. So when it is generated in the system, then it will automatically kill the pathogen which is there. So as per the BI is called 0.5 milligram per liter is required. So we already have the information here. So I think this data will also tell you that okay, this self-automated chlorination system or disinfection system is a must of the era. You don't have to depend on a manual. So I'll not talk about this. So I would like to thank the platform and also the funding agency will support this project. And I think that's my thing. Thank you so much, ladies and gentlemen. If you have any points,
Thank you, Dr. Mendelson. I'm sorry to push you, but I think that you have a good grassroots innovation, and I'll request my youngster friends to interact with you while you are here. So it's a wonderful grassroots innovation. I think that we can give a big round of applause to this innovation. Thank you very much. So the next, so Vikash Mushahari, please, I already announced the name, so if you people can line up before, that will be great. And I asked you that please hand over your USB sticks beforehand. The next one, Peteris Basumajari, will you please hand over your USB stick to the desk? Dr. Pankaj Hazarika. Dr. Pankaj Hazarika. Yeah, please hand over your USB stick in advance. Already there. Thank you. dAY. dAY. Would you please hand over your USB stick and someone can help them with while they are presenting. I think that they can still load that. You see, we should save this time, gentlemen, if we can tell them they can load it beforehand. Mr. Vikash is not there. So, yes, so go there. Your turn. No, I'm saying Vikash Kusari. So, Vikash is not there. Mr. Vikash Shahari. Absent. So, please, Basumajari, please. Yeah, you please.
very good afternoon to the respected chairperson and all the dignitaries. I'm here to give my own presentation on the topic response surface methodology for the optimization of synthesis of nanocellulose from banana rushes and its characterization. So, next. So the focus of my current study was to valorize nanocellulose synthesized from potential green-based raw materials, that is banana nutries, which has sustainability, and isolate nanocellulose from it and go for its characterization. So before going into the detail, I would like to give you an idea of why I've chosen this particular banana nutries. Actually, the banana nutries from which I've taken is from the variety Jahaji, and it is grown throughout the year, almost throughout the year. And actually, it is one of the most widely adopted commercial banana, owing to high yield, wide market potential, ability to withstand, and highly economic. And it features high price in the market for good shape, size, and delicious taste, but the vast utilization of these crops are awaiting commercialization and value addition. So this is the sequence of steps which I follow for the isolation of nanocellulose. I won't go into the detail, it is given as such. This is the image of the images I have taken during the experimental analysis, and you can see the raw banana trace has been converted to dried one and then powder, and then there are some treatment, and then I was able to get the nanocellulose. And then I've done the optimization of the process while taking out the nanocellulose using high pressure homogenization. And the independent variables I've taken as pressure, passes, and concentration, and the coded levels are given as such. And the design I have used here is box pumpkin design. And this is the responses obtained from particle size and zeta potential, and there are total of 17 runs, and the responses has been recorded as such. And this is the analysis for variance table for the quadratic model for particle size, and as you can see, the model is found to be significant, and the lack of fit is found to be non-significant, and the R-squared value is found to be 0.98. And the quadratic equation is given as such. And this is the analysis of variance for zeta potential. And here also we can see the model is found to be significant, and the lack of fit is found to be non-significant, and the R-square value is around 0.96, and the equation is given as such. And this is the 3D surface graph for particle size. And from the graph A, we can see that if we increase the pressure, the particle size decreases. And if we increase the passes as well, the particle size decreases. Similarly, we can see that if we increase the passes, the particle size decreases. And this is a 3D surface graph for zeta potential. And from graph A, we can see that if we increase the passes, the zeta potential initially increases and then decreases. Similarly, for passes as well, the zeta potential initially increases and then decreases. And there are graphs for concentration and passes, and as you can see, the zeta potential initially decreases and then increases. This is the optimum condition experimental predicted value of responses at optimized condition. And this is the, you can see there are predicted value which is found to be 138, and the zeta potential is around minus 12.67. And after doing the experimental analysis, I was able to get the particle size of 122.4 nanometer and zeta potential of minus 10.1. And and the desirability was found to be 0.92, which is acceptable. This is the result of the experimental data. As you can see, the graph, it goes with the whatever the result I have got. And this is the image of the nanocellulose which I have obtained. And this is the FTI. Further, I have done the characterization. This is the FTI graph for the nanocellulose, banana nutries, and the cellulose fiber. And this is the And this is the XRT graph of the banana resins, cellulose fiber, and nanocellulose. And we can see that after doing the chemical treatment, we were able to the crystallinity of the nanocellulose increases from 31 to 69.08. And this is the image of the banana resins, cellulose fiber, and nanocellulose. And from the graph, we can see from the smooth surface how it gets converted to individual fiber. And this is the dAY analysis I've done, and this is the first order derivative of the results. Thank you so much.
Thank you very much. Sorry for pushing you for the time. I'm sure that you see the idea of oral presentations is that someone presenting amongst you, so you can buy inspiration and you can talk to the people. And to be brief, I'll only say that explain to your friends that why on XRD we always take 2 theta and not theta. Usually we do not take the double of everything. But in XRD we take 2 theta, we never take theta. Although theoretically we can just divide 2 theta by 2 and we can put theta, but we can't do it. So explain to your friends, and some of other of my younger colleagues might also be intrigued by this, that why we take 2 theta. Thank you. So next one, Dr. Pankaj Hazarika. Yeah, the floor is yours. Please stick to the time. I'm also hard pressed to like at 2 o'clock. There is another program. Thank you. Thank you very much, Dr. Hazarika, Assistant Professor, Mahadev University, Nayanpur, Assam. Micro-array games in Fajr. Thank you.
Respected Chairperson sir, and my topic micro-array games in Fuzzy environment. Since it is a mathematical topic, so I will try completely avoid all the mathematical terms here. Just I will explain what is the meaning of this. Like, so first of all, cooperative game. What is the cooperative game? Sometimes it is we have seen that we are assembled together to generate some word. That word may be sometimes cost, that word may be sometimes profit, or that word sometimes may be responsibility. So the main task is that after generating the word, how can we distribute that word to the individuals? So that is the cooperative game. Then the next is the fuzzy set. What is the fuzzy set? Suppose if I am asking you what is this, do you know what is this? Then your answer will be either yes or no. But there may be sometimes intermediate situations are there. So it seems to be a mobile phone, or it seems to be other things like that. So in that particular sense, the fuzzy sets comes here. So in here also we are using fuzzy sets. So I will discuss here. So then the next I will explain microarray experiments. What is the microarray experiment? The microarray experiment is used to generate the expressions of the genes. So it is after getting the expressions of the genes, always it is necessary to find out which one gene is responsible for occurrence of a particular disease. So here. So in mathematical term, the cooperative gain is a pair NB, where N is the pair set and V is the gain here. That means then he will generate the what? It is called like characteristic function in terms of mathematical terms. So while doing this work in the biological field, it is sometimes we need to find out the expression level of the genes. So while evaluating the genes, so we are using the overexpressed genes and underexpressed genes. So whenever one gene is overexpressed or underexpressed, then we will say that particular gene is an abnormal gene. So we are doing on that particular abnormal gene. So in here we are using fuzzy. That means I'm not directly saying that this particular gene is abnormal gene. We are saying that this gene is abnormal to particular this extent. So like this we are incorporating the fuzzy set in the microarray experiment. So in this particular microarray experiment, we are defining one particular gain here. This is the mathematical part. So while doing the finding the genetical expressions, so this is the description and translation. This is the procedure to find out the level of expressions of a particular gene. Then the later on, so this is the one picture of the how can you find out a microarray experiment. So this is this one, and the later on, so So from this particular microarray, so we will get this type of expression values here. So in my work, what I am doing, I am giving some linguistic value here, that is to highly expressed, under expressed, little expressed like this. Then after that, I will normalize this particular linguistic variable to a binary variables, either 1, 0, or to some other part. So like this way, I am defining this microarray games. So in my situations, the players are the genes, and they know the decision. What is the decisions are there, and so this is the level of, suppose I am taking three genes, gene 1, gene 2, and gene 3, and they are the expression levels in the normal cells and the damaged cells. So like this, then I will get the set of abnormal genes, the gene 2 and gene 3 in these particular examples, and in the later on then I will get the three genes from this particular array. I am getting these three genes which are abnormal genes. So then after that, my work is this. These are some examples here. So my work is this one. It says I am defining this particular game in the fuzzy environment. So this particular game of QS, I am trying to find out the gene expressions in a fuzzy environment. Then after that, I have defined this particular solution. So from this particular solution, I will try to evaluate which one gene is more responsible for occurrence in a particular disease. So like this, I will get the responsibility of that gene from this particular solution. So that's all this reference is. So there are lots of mathematical works behind this. Just I am trying to skip all this. So that's why.
Thank you. Yeah, thank you, Dr. Pankaj. I think that you just tried to tell that there is a logic, not even in the gray, black and the white, but in the fuzzy area also. So thank you very much. Next, Mr. Bikash Dey from Department of Physics, Central Institute of Technology, Kokrajhar. New promising materials for spintronic devices. D0 ferromagnetic oxides. Please, next, Dr. Ranjit Datta, Dr. Femina Brahma, Dr. Suresh Kenar, and Mithinga Basumatari. Please stay put. Thank you.
Very good afternoon to all of you present over here. So respected the chairperson and co-chairperson of this session. So now I am going to discuss about my research paper on the topic new promising material for spintronic devices, which is D0 ferromagnetic oxides. So at first I will discuss about what is spintronics and what are the materials applicable for spintronic applications. So spintronics is basically is a branch of science which deals with spin of electrons. Basically, in conventional electronics, only spin of an electron is utilized to store or process data. But in spintonics devices, both charge as well as spin degree of freedom of an electron is utilized, providing significant advantages over conventional semiconductors, such as fast data processing speed, low volatility, high storage density, etc. So now, in various branches also, spintronic devices are applicable, such as in biotechnology, nanotechnology, and information technology also, spintronic devices are applicable. So now, we are looking for a material which is applicable for spintronic devices. So for spintronic devices, there are some criteria or there is some condition. So first, for spin-based materials, semiconductors with ferromagnetic properties are desired material. Moreover, in various actually researchers initially do transition metal doped semiconductors, but uh, there is some limitation. Actually, there is some drawbacks in transition metal doped semiconductors, which is also called dilute paramagnetic oxides, which is called DMX. So, uh, actually, in such materials, the origin of paramagnetism remains controversial. That is, whether it whether it comes from uh, the magnetic impurities or it is intrinsic properties. So that's why one alternative material known as G0 ferromagnetic oxides was projected as promising clean material for spintonic applications. So now, motivation behind this work. So after having comprehensive literature review, uh, we revealed that the field of T0 ferromagnetic oxide is in growing stage, and lots of research in this field to be done to advance this field of research. So in this work, basically, uh, we highlighted several integrating features associated with few non-magnetic oxide doped materials. So now we also a detailed study of crystal structure, microstructure, optical and magnetic properties of silver doped zinc oxide, potassium doped zinc oxide, magnesium doped zinc oxide, and sodium doped titanium oxide also. So out of which I am showing the results of potassium doped zinc oxides. So to prepare these materials, we have used solid state rod technique. So these are the techniques we have used. At first, we choose starting materials. To prepare these compounds, we have chosen the starting material, zinc oxide and potassium carbonate. After that, as per stoichiometric ratio, the materials are weighted and mixed them thoroughly under acetone. After that, the mixtures are presented in several temperatures, 300 degrees Celsius, 500 degrees Celsius for 10 hours, and then 800 degrees Celsius and 1000 degrees Celsius for 20 hours. So in this way, our sample has been prepared. Now we go for characterization. So at first, to study the crystal structure of the synthesis samples, we have done XRD. And this is the XRD pattern. From this XRD pattern,
Vikash, we are out of time. You spent so much time on the introduction. I told you that the time is time. I give you 30 seconds to show your conclusion. Okay. Yeah.
so we have done XRD. From this XRD, we have seen that the samples have been crystallized in single phase. Then we have done microstructural analysis to study the microstructural study. We have done SAM. And then from this EDS spectrum, we have seen that the composition of the sample is quite similar with the starting material.
Conclusions, please.
And this is the conclusion. So from XRD, we have revealed that our sample is in single phase. From SAM analysis, we revealed that the sample has uniform morphology with average particle size 3 to 6 micrometer. And from optical property, we have find out the band gap. And we reveal that the band gap decreases with potassium doping concentration. And from the magnetic property, we reveal that the sample is ferromagnetic behavior. All the samples shows ferromagnetic behavior. So these are the list of papers which I have published in a very reputed journals. And this is our research group. Thank you. Thanks a lot.
Yeah. Thank you. Thank you, Mr. Vikash. You can just interact with him during the break. Dr. Ranjit Datta. Dr. Ranjit Datta, will you please? And the next three speakers, Dr. Femina, Dr. Suresh, and Nitinga, you please stay put with your presentation. Yeah, so please stick to the time. I'm sorry, brother.
Everybody, I am here to present some preliminary data on my study, assessment of water quality status of Likrom River using water quality index in Lakhimpur district of Assam. So we all of we know that what is water, why water is important. I'm not going for this. So the Brahmaputra and the Barak River basin of Northeast India, we know that are extremely rich in water resources, which form 8% of the country's spatial dimension is endowed with 33% of country's water resources. So therefore, the water resource of Northeast India is very, very much important nowadays. The Brahmaputra River basin spreads over countries of Tibet, China, Bhutan, India, and Bangladesh, having a total area of 580,000 square kilometers. And this is Brahmaputra River basin. And the other river system of Northeast India is Barak River, then Barak River, Gumti River, Middu River, etc. and some of the major river flowing to Bangladesh, while the Alada River and the Manipur River, Izu River, etc. flowing in the states of Mizoram, Manipur, Nagaland are the main river flowing to Burma. So this is Barak River system. So my study area is Dikrom River. The Dikrom River is one of the major tributaries of the northern side of mighty river Brahmaputra. That river originates from the altitude of 2,579 meters from the Sirang Getu Hills in Arunachal Pradesh. So it occupies a total area of 1,525 square kilometers, and out of which 1,250 square kilometers falls in Arunachal Pradesh and others in Assam. So I am not going for this. So I have studied the two study sites. One is Bandodwa and another one is Sisapathar. So materials method I am not going for this. So this is the one I have taken from Google Earth. This is Dikrom River systems. So this is details of sampling location. Bandodwa, another one is Sisapathar. So water quality index, what is water quality index? The water quality index represents a large number of water quality data to a single numerical value. It signifies the composite influence of various water quality parameters on the overall quality of water. So water quality index 0 to 25 is excellent, 26 to 50 good, 51 to 75 poor, 76 to 100 very poor, and above 100 it is unsuitable for drinking. So my result is here. So you see the results. This is study site 1. So I have studied 7 parameters: pH, water temperature, electrical conductivity, total dissolved solids, dissolved oxygen, BOD, and turbidity. So this data is for site 1 Bandodwa, and this data for site 2 Sisapathar. Here also I have studied 7 parameters. So from my study, I have found that in the study site 1, the water quality index is 75.0300, and which is for water quality status is very poor, and another one is Sisapathar, that is 61.2301, it is also poor. So compared to Sisapathar, the Bandodwa water of Bandodwa study site is very poor. So discussion, assessment of river water quality is a primary requirement for emerging public health problems in this context, where availability of safe water is at risk due to natural and man-made activities. The present study is a fact-finding or exploratory study contributing to designing and improving program interventions which cover larger population areas. So the water quality index of Dikrom River in both the study sites is of poor quality and must therefore be treated before use to avoid water irritated disease. The application of the water quality index in this study has been found very useful in assessing the overall quality of the Dikrom River water. So my conclusion, the Dikrom River need to be protected from domestic as well as industrial contamination. Not only Dikrom River, all the river systems of Northeast India should be protected from domestic as well as industrial contamination. The promotion of an awareness campaign among the local people is required to maintain good water quality. The protection, conservation, and rejuvenation of the river must be treated as an important regional as well as national issue. So this is I have taken from this internet. So the river systems of Northeast India. See, thank you.
Thank you very much. I think that the future perspective for your lecture can be that you collaborate with Dr. Mendelson. So now you find the WQI, which is not satisfactory, and you can collaborate with Dr. Mendelson, who can just purify that water. Thank you very much. That can be a very wonderful collaborative work. Dr. Famina Brahma, Department of Physics, Central Institute of Technology, Gurgaon, optical and magnetic properties of multifunctional solid solution of lanthanum dot BFO-BTU. Thank you. Please stick to time and also to our press to press you for that. Thank you.
Thank you. Myself is Femina Rama, and today I am presenting a small part of my work, optical and magnetic properties of multifunctional and solid solution of lanthanum dot BFO BTO. Actually, the work is on the perovskite. Perovskite is a material of the structure of AbO3. This is the structure, general structure of AbO3. Here is our anion and B is cation and oxygen. So in this structure, we have docked rare earth material lanthanum with the BFO-BTO. So why I have chosen the BFO-BTO? Actually, BFO-BTO has a good characteristics of magnetoelectric and it can be used as a multiferric material. So the rare earth was chosen because in today's days, lead is used as a material for this renewable energy sources. But when we give the lead, so it's not good for our environment. So we have tried to change the material, the lanthanum, which is a rare earth material for the synthesis of materials. So the lanthanum we have chosen in this material. So this is the mixed oxide solid state reaction route through which we have prepared our prepared samples for our work. So we have taken the highly raw materials, then dry mixing, wet mixing, then calcination and grinding. After pelletization and sintering, we have done the electroding on the material, then we go for the characterization. So the results and discussions based upon the various characterizations. The first one is the XRD. Through the XRD, we are able to see that whether the material is formed or not. So in our XRD pattern, it is clearly seen that it's a single phase material which was formed, and also the rapid analysis was done to see the material's phase formation. And it is the size of the material we have got was 23 nanometer. This is the parameters, lattice parameters, and the crystal size I have determined from the XRD. So it's an orthorhombic orthorhombic material. The same microgram index mapping is clearly seen from the graph that the grain and grain boundaries are formed in our material. Then the index mapping is giving us the information about the presence of all the expected materials. So next is the dielectric spectroscopy. In this dielectric spectroscopy graph, we are able to see that the dielectric is quite decreasing with the frequency. And the reason for this is that the pop-up of the grain and grain boundaries and the 10 delta, which is a very important for making any kind of materials, that is very low in our materials also. So impedance analysis, in the impedance analysis, this impedance analysis gives us the information of the relaxation behavior. That means the material which we have prepared is anti-shear behavior. And the main topic which I want to represent in this platform is that optical behavior, which is a UV visible spectroscopy. Through optical UV visible spectroscopy, we have done the optical analysis through Wood and Tau equation. So absorbance is in the range of 609 nanometer in the case of BFO-BTO, which is our base material, and EZ, which is our EZ is 2.23 electron volt. Now let's see in the next that this is the doped one. In this dop, we are able to see that it is 2.62 electron volt. That means the lanthanum is enhancing the EZ. So we can say that it's a good quality for semiconductor behaviors. Now the magnetization analysis, we are able to see that it is giving us the through the vibration magnetometer, we are able to see that residual magnetic
1.811%. The non-zero value of magnetic parameter indicates that the sample possesses the paramagnetism behavior. That means it can be used as a memory device. So this magnetic behavior is due to the iron oxygen titanium iron oxygen structure. That means the presence of the heavier ion platinum at the A side leads to the structural deformation, and the tilting of FeO6 octahedron affect the iron oxygen bond angles. Thus, doping of the lantana ferrite gives us a good quality of the magnetic property to the system. So this is my conclusion. So we can use this for all devices. Then this is the feasibility for device application. Some references, and then acknowledgement, and then thank you.
Thank you for sticking to the time, Dr. Shamina. It's a wonderful work. Farouk's slides are really useful. Can you give me some sound, please? Yeah. So thank you very much. So next, Dr. Suresh came up. Dr. Suresh, and then the next one, Mithika Basumadari. Please be in the queue. Please stick to the time. Thank you.
Good afternoon, everybody present here, respected chairperson sir and other dignitaries. Today I am going to present a topic that is the fluoridation of water using limestone and some common acids. So we know about the pollution that is created by fluoride that is present mainly in groundwater. So there are a lot of countries as well as in India. There are a lot of areas where fluoride is having the water. And this is a case in some, actually the fluoride is needed for our body use. That means normally in our teeth and bone, calcium hydroxyapatite is present. So that calcium hydroxyapatite is strengthened by a little amount of fluoride. So that is why whenever we go to a doctor because of some teeth problem, doctor used to prescribe sometimes a toothpaste which is having high amount of fluoride. So that can strengthen our teeth and bone. But the problem is, if the amount of fluoride is very high, then it also degrades our teeth and bone. Now, these are the situations they are alarming in Rajasthan, Gujarat, and in Assam also, in Karbi Anglong as well as some parts of Nagaon district, lot of fluoride is present in the water. So we have done some works on this, and we have also developed one method. These are some situations that you can see the legs of the children are bent. It is because of the presence of fluoride which has degraded the bones of the children. So to overcome this problem, we have developed one method, and I'm skipping all these things. How it comes to groundwater? These are some rocks that is having fluoride, which slowly reaches to the water, and it ultimately comes to the groundwater. So this is now here you can see that this hydroxyapatite, when it reacts with fluoride, it becomes fluoroapatite. So this fluoroapatite slowly degrades our teeth and bone. So there are some problems that occurs in our teeth, and these are the situations what happens when we have more than 1.5 milligram per liter fluoride in the water that we are drinking. So to overcome this situation, we have developed one method that is called acid-enhanced limestone defluoridation. Or if you type in the Google fluoride nilogon, in Assamese the nilogon word is meaning is removal. So if you type in the Google, you will search the images, you will find many examples where this type of fluoride removal unit is installed in many places like in Assam, in Rajasthan, in Odisha, where the problem is there. And recently that method has also been used by some people from abroad, that is in Yemen. So the same method, but I have done a little bit different work here. That in India there are a lot of limestone mines everywhere. It is there. The black spots all are limestone mines in the map. So in this method we have developed. We have got also one patent, Indian patent, and now it is a very simple method. But here in our Kokrajhar Government College, we have tried by using a different acid, which is added to the water before filtration through a limestone column. So we have found that almost 98 to 99% of fluoride is removed from that by using this method. We simply use limestone in a container, and there we add some water which is having fluoride as well as some amount of acid. So we keep it for some time, and then we filter it by a normal filtration method like sand gravel filtration method. And simply that water can be used for drinking or as well as some other purposes. So these are some results, and we have proved these results by using some XRD studies and as well as by using some uh, other techniques. I have not presented all those things. So in the laboratory, by using common laboratory acid like sulfuric acid or like hydrochloric acid, we can easily remove the fluoride. But only the thing that we need is limestone. And in Karbianglong district of Assam, the people are taking the limestone from Bukazan cement factory, and they are preparing the filter by themselves. Only the instruction that we give is the how much amount of acid they have to take, and that is also given by the school teachers, BSc or science teachers. They used to prescribe the amount of acid that they have to take, and they are filtering their own water. I mean, by using this simple method. Thank you very much for your patience.
Thank you, Dr. Suresh. It's a really, really useful work. I just have two quick comments. I'm not a doctor, but one thing is try to address this issue. You see, the doctors prescribe the fluoride paste, and we just keep on using that fluoride-based paste even without knowing how much fluoride is in our water. That is one thing. Second thing is there are certain coastal areas in India where the fluoride is too high, but people are not getting affected by this fluorosis. So try to have that, the coastal areas, some of the coastal areas on the western side of the country. So just try to study why they do not have this effect of fluoride, although they have a very high fluoride in their water. That can give you a wonderful insight. Maybe there is something in their food, natural food, that is taking as a natural decontaminant, detoxification against fluoride. Thank you, very useful study. And last but not the least, I welcome Mithinga Basumatari from Department of Mechanical Engineering, Bineshwar Brahma Engineering College, Kokrajhar, experimental analysis of improved performance of harmonious turbine with a combined lift and drag based blade profile for low head river application. Thank you. Please try to stick to the time.
Good afternoon, everyone. Myself, Mithinga Basumatari from Bineshwar Brahma Engineering College. Today, I stand here to present on the topic called experimental analysis of improved performance of 7 years water turbine with a combined least and drag-based blade profile for low head river applications. So this is some of the presentation outline. I was about to give a brief introduction about it, so I'm skipping for the short of time. So firstly, we'll have to know what is a 7 years turbine. Okay, it is a A-shaped light turbine which is simple in design. It is easy to fabricate, and it works like a cup anemometer, and it requires a low wind or water speed for the operation. And it consists of two half cylinders for the opposite directions to have an S shape, and its maintenance is very low, and it is reliable, it's self-starting, it is omnidirectional, and there are many applications for this type of turbine in day-to-day life. So firstly, we have to know what is the advantage of it and also the disadvantage of it. The disadvantage is it is simple in design, as I have already discussed about it, and it is easy to fabricate. It requires low wind or water speed for the operation, and its maintenance is low, and it is reliable, self-starting, and omnidirectional. But besides of having so much of advantage, it has various disadvantages also. So some of them are the scoop system, which is used to capture the energy, is half as efficient and the conventional turbine, which is resulting in less power generation. And mainly, the 7 years turbine have a poor efficiency, and the torque variation along the angular position of the rotation is very poor. And also the contribution of the leaf forces in this type of turbine is negligible. So these are some of the review which I have done. Now after completing the review, like I have found some of the research gap and the present contribution in this paper. Okay. Now the drag-based harmonious turbine is a self-starting in nature, and the majority of the researchers have changed the design parameters like the blade overlap ratio, blade gap ratio, aspect ratio, etc. to improve the harmonious turbine performance. Basically, the main objective is to improve the performance of the turbine. And also some of the researchers have modified the blade shape of the turbine like using the helical blades and also the combination of the straight and the curved blades and the twisted blades, elliptical, and instead of the curve of the blade to improve turbine performance. Normally, these blades are mainly used to utilize both the drag and the leaf forces for the strain and the curve for obtaining and harnessing the maximum of energy from the water or the air. And finally, like this is my objective. That is the experimental analysis of the improved performance of the Savonius water turbine with a combined leaf and drag-based bed profile using a low head river applications. So this is the 3D CAD model. In the figure 1A, we can see the proposed CLD turbine and the modified 7 years water turbine. And in the figure B, we can see the experimental model of the proposed CLD based model 7 years water turbine. And in the table 1, we can see the some of the geometrical parameters which I have considered during the construction. And these materials, the materials which I have constructed is of the acrylic material. The material used for this shaft in the frame is of the pine steel, and the materials which are used for the bearing, which is of cast iron. And the blockage ratio considered for this setup is of 1.68%. This is the schematic view of the experimental setup which I have done through from the water tank. The water has been pumped with the help of the pump and then sent to the channel, and where your CLD turbine has been placed in the channel, and ADV probe has been placed in the channel for measuring the flow velocity, and which has been connected to the high velocity port and also the ADV fill processor, where we can see the fluctuations taken place in the water flow. And the water flow can be adjusted with the help of a water regulator, adjustable discharge gate with the help of a regulator. And the channel length is of 12.95 meter, that is, and the channel width is of 0.9 meter, and the channel height is of 0.7 meter. This was the experimental setup of the open channel flow which I have carried out, and the figure 3B where the ADV probe has been immersed inside the water for the measuring of the water velocity. And this is the test rig in the figure 4, the experimental setup of the proposed CLD turbine. And some of the, before proceeding to the experimental analysis, we have to
Sorry, please proceed to the conclusions.
Okay, these are some of the maintenance of the flow uniformity, and these are some of the turbulence intensity and the channel which I have carried out. And for the bottom analysis also, the nature of the curve was the parabolic curve. This is the details of the open channel flow. And this is some of the studies which I have carried out. And this is some of the performance parameters like the coefficient of performance and coefficient of torque at different TSRs at velocity 0.5 meter per second. And lastly, the comparison has been done along with the different study, and it has been seen that the optimized CLD turbine is best at the diameter of 260 mm. So these are some of the conclusions I have drawn from my study. These are some of the references.
Thank you. Thank you. Sorry for pushing you.
Thank you.
Here we come to the end of our session. In general, quickly, if I have to say, I can simply say that the communication as well as the methodology presented by all the 8 speakers, 8 young researchers, I believe is definitely better than what I expected. Just a quick word. So please, I think join me once to give a big round of applause to all the 8 young speakers for this session. Just a quick word that to my younger friends, I'll say that we should never try to bring our cut and paste figures from our paper to an oral presentation. The paper is different than an oral presentation. And once again, I'm sorry because all blame is on me. I was handed over the mic in the end to say that we have to finish by 2 and we are running 3 minutes short. So I think that I hand it over to Dr. Rebecca Demani for the next proceeding. Dr. Rebecca, please.
Good afternoon to everyone, respected chairperson, and all the invited speakers, and also the participants and audience here. So it gives me immense pleasure to deliver the vote of thanks on behalf of the coordinating committee. So first of all, I would like to thank Professor S. Arya for delivering a wonderful speech on the contributions of society, the contributions of science and technology for the society and also for the aftermath of the exhibition. And also, I'd like to thank all the other presenters. All were wonderful presentations. So thank you all for presenting your research works. And also, I'm thankful to all the audience who have come here and make it a grand success. So thank you all.
Now I would request all the participants, guests from Science and Technology Department for a group photo. Please come quickly near the dais. From the first station, including our honorable guest. Science and Technology session, all the participants, guests, visitors, please assemble near the dais. We will have a joint photograph of all.
মোবাইলটো যদি তেওঁক দি দিবা তেওঁ ফটো মাৰিব সেইটো মোবাইলটো মাৰিব ওলাতে মাৰি দিব
We have the certificates ready for oral presenters. Okay, so you can yes, you can connect all those certificates from Dr. Rajshekhar Boria. And the poster presentation will be held in the venue Computer Science Department. So I have already once I told that it will be ready for evaluation from 3 p.m. onwards. Okay, so at 2, all the poster presenters are supposed to hang their poster in the venue, and from 3 p.m. onwards, poster evaluation will take place. Thank you. With this, we come to an end of the first session, that is Science and Technology in this Borderland International Knowledge Festival. Thank you.
Light changer আছিল নেকি? Light changer. কোনটা? और 2 सेक्शन है ना।